Now what I want to do is talk to you a little bit about strings. So it turns out that JavaScript is a little funky in their model for how strings are handled, and you'll see why in a second. So I could do something like this with a string. Oops. I could say var s equals hello world. And you're saying, okay, yeah, that's a string, but this is actually called, this is actually a simple type, not a complex type. Let's do another one. Var x equals new string hello world. Now this is a complex type. So if I were to say console.log x.substring 0, 5, what that would do is it would get me the substring that starts at 0 and goes to 1, 2, 3, 4. And 5. So it would output. Oh, I'm sorry. It's it's the length. So it's going to be substring starting at 0, start, and that's length. So 1, 2, 3, 4, 5. So it's going to output hello to the log. Now, curiously, I can also do this. I can say s dot to upper case. And this will give me hello world. Now, why would it do that? And this is a valid complex type string method, but S is a simple type. So basically, JavaScript allows methods and members for on simple types that map to complex types. So that's really complicated because S really is a simple type, but yet we can invoke methods like toUpperCase on S, even though S is not a complex type. And I think that the authors of JavaScript just thought this was a nice convenience mechanism. So you could jump back and forth between a simple string and a complex string. The complication is that as a programmer, it's really annoying because you're trying to build a mental model of how data types are managed in JavaScript, but the language keeps violating the rules for how those data types are managed. So, is it a simple type? Is it a complex type? Does it matter whether it's a simple type or a complex type? How's that all managed? Well, JavaScript has lots of exceptions to how that works. Now, there's a whole bunch of other members and methods that you can look up on about simple types. And what I would advise doing is going to, let's just bring this up, see how long this takes to appear. You can go to JavaScript string type. And if we look, I really like the W3 schools. And look at JavaScript strings. And it gives you some examples of a string type, and then shows you a whole bunch of methods. Let's go back up here because that's not the right one. JavaScript string methods shows you a whole bunch of string methods that you can execute. This is still not right. String class. Let's try that. There we go. All right, here we go. And let's take a look here. So we've got index of, which is awesome. So you can search for a string within a string. We've got split, so you can split a string into an array of substrings. There's substring, which we used. We just looked at 2 uppercase. There's also a 2 lowercase. So you've got all kinds of juicy string methods that you can look up. And you can look this up under w3schools.com. And you want to look for what they're calling it here is the JavaScript string reference. Okay. You can see there's a whole bunch of other types as well. There's number, which we talked about, so there's lots of other members and methods you can mess around with for the number type. There's date, which is cool to mess around with. There's math, which we just talked about, and there's a few other classes as well, basic classes. Okay, all right, let's go back here. So I want to talk now about something called type coercion. So type coercion is basically what JavaScript will do to a type to convert it into another type. So I want to give you an example. Let's take a primitive string, August, and and a number, 1997. And what's the result of this? We end up with a primitive string, August 1997. Now, how did that happen? Well, what happened is that this was a type, which was a primitive number, was coerced to string in order to make this expression work. Here's another one. 1997 plus 1 plus August. What do you think that's going to evaluate to? Well, first, this 1997 is going to get computed, and that's going to give us 1998. We're adding up 2 primitive numbers types. And then the 1998 is going to get coerced to a string, and we're going to end up with 1998 August. Okay, so far so good. Gets interesting though. What if we do this? 1 plus 1. That's going to give us 11. 3 times 2. Oh, that's going to give us 6. Oh, that's annoying. And 3 times 2. That's going to give us not a number. So, what's a programmer to do given these situations? Well, You can come up with a set of rules, but they're not terribly consistent. I mean, this is clearly both a concatenation operator and it's a number type operator. So the rule is that if strings are involved, plus will coerce number to string if any number is string. And the other operators that you might see with numerics, multiplication, division, modulus, and minus, will coerce number if any operand is string. So I said up here, I said number, but what I really meant to say is operand. Okay. Awesome. So let's look at a little more, a few more examples of coercion. So here I have var n equals 42. So this is clearly a primitive number. And if I were to say console.log n.2 exponential, well, n was a primitive. However, it's going to get coerced to complex type, complex number, and then the exponential will be applied to it and will end up as output 4.2 e plus 1. Okay. Here's a string. Var s equals new string hello. So that's clearly a complex string. And if I were to say, what is the type of S? Type of S, it's going to say that S is an object, complex type. All right, and then if I say S equals S plus world, what will happen is this world will get coerced from simple type to a complex type. I take that back. If I say S equals S plus world, interestingly, it's going to coerce the complex type to a simple type. That's interesting. And if I were to say console.log type of s, it's going to output string. Okay. If I do the following, okay, I'll keep going here. So let's say I continue, and let's take a look at some numbers. So there x equals new number 42. So I've got one complex number type. There y equals new number 1. Got two complex types. And then I say console.log x plus y. Oops, I want to change that slightly because I want to output the type. So let's change this to type of x plus y. What I'm going to see here is number, the primitive type. Very interesting, huh? So the rule here is that JavaScript will coerce from primitive to complex and back as needed. And if you're dealing with a primitive object that has a parallel complex type, and both the objects are involved in the same expression, JavaScript will attempt to downcast the object into the primitive type, which to me seems unintuitive, because I'm used to things in Java where Java looks at something that's primitive and upcasts it to a more complex type. So, for example, if you take an integer and a double, the integer is more primitive than a double. That's one way of thinking about it, I guess. That's the way I think about it. And it's coerced into a complex, more complex data representation of a double. Okay, so there's just one more example I want to give you about coercing types, and that is this. You can do type coercion explicitly if you want. So everything that happened above was implicit. I didn't say anything about how to do the coercion or what kind of coercion was going to happen. JavaScript just did it for me. So here, I'm going to be explicit. There n equals new number 42. So here I'm saying take this primitive string and convert it into a complex number. And I can do the same thing with a primitive number. I could say there s equals new string 42. And now I'm taking a primitive number to a complex string. Okay. And last but not least, let's take a look at, I'll give you an example of one more implicit coercion. If I were to say var t equals 42 minus 0, I think using the rules we have up here, if we have minus, the rules for coercion are, if we have a minus, we're going to coerce the to-number if any operand is a string. Okay? So I'm going to take the value here and coerce this to a simple number, and we're going to end up with t having the value of 42. Okay, awesome. All right, that's it for type coercion and strings.